Hello, we are going to talk about dimensional analysis. I love dimensional analysis. This is fundamental. If you can do dimensional analysis, you can almost do anything in science. I'm not joking. Dimensional analysis is the power of units and the power of dividing or multiplying by one. I personally love dimensional analysis because the units tell you what you have to do. You don't have to think, and honestly, I try and think as little as possible. So I love dimensional analysis. We're going to start super basic with something you already know. Let's talk about conversions between feet and inches. So you know that the relationship is 1 foot contains 12 inches, and that's probably how you've seen it written. You could also write this as a ratio. 1 foot contains 12 inches, and guess what? That can also be written as 12 inches are in 1 foot. They are both true statements, okay? They're both true statements. Now, let's say that I have 1.5 feet, and I want to know how many inches are in that. I bet like that you just did it in your head. You know the answer is 18 inches. So 18 inches, let me show you what your brain did. Let me show you what you did really fast in your head. We're going to use dimensional analysis, and I strongly recommend in any science class, this is the way you do conversions with units. We want to get rid of feet and we want to end with inches. Inches, that's our question. You're thinking algebra. You want to get rid of feet, that means you have to put that unit on the opposite side of the fraction so it cancels out. What we want are inches. Now let me step aside and review the algebra with you really quick. If I had x times 1 over x, that just equals 1 because the x's cancel. It's the very same thing here. If I do feet times inches over feet, so just looking at the units, check it out. Feet cancel, and I'm left with inches. That's what I want. So once we have the units, and by the way, I always write the units first. Always write those units first. Once we have the units on there, then we are going to add the numbers. So I know that there are 12 inches, 12 belongs with inch, and 1 foot. Now a common mistake, students will add the 1.5 here somewhere into this ratio. When you write down the number you begin with, you never write it again. This is always a ratio, and the ratio usually has the number 1 in it, that we're referencing one item compared to something else. Okay, so now we do this math. 1.5 times 12 is 18, and then again, the feet cancel, and we're left with inches. So let's do this with metrics. Let's say that I have 275 meters, and I want to know how many nanometers, let's do nanometers, are in this. Okay, I've memorized my base units and I've memorized my prefixes. I know that there are 1 billion, 10 to the 9 nanometers in 1 meter. So I want to get rid of meters. That goes in the denominator, so it'll cancel. Woohoo! Nanometers, that's what I want. Now I'm going to attach the numbers. So 1 meter contains 1 times 10 to the 9 nanometers. So if I multiply this, meters cancel, 275 times 1 times 10, 10 to the 9 is going to give us 2.75 times 10 to the 11 nanometers. Now I want to show you something that I did. I like to think how many items fit inside a meter stick. So there are 1 times 10 to the 9, 1 billion nanometers in a meter. If you look though on the internet for any prefix, this is how they write it. They will say there are 1 times 10 to the minus 9 meters for every 1 nanometer. They do this as 1 nanometer is a billionth, 1 billionth of a meter. I don't like using this because it's a fraction. My brain just works better thinking in wholes. How many nanometers are inside of a meter? You can do it either way, and you'll notice if I had put this up here, you get the same answer. So whichever way works for you, whichever way works for you. Let's do one more unit conversion. Let's say that we've got 30 microseconds. 30 microseconds. And I want to know how many milliseconds, this is. Well, I don't know how many milliseconds are in a microsecond. So when you have to go between different prefixes, what I recommend is to bring it back to the base one. Bring it back to the second. Or maybe if it was micrometers, you bring it back to just meters. All right, so I'm going to bring this to seconds. I'm going to get rid of the microseconds, put seconds. I know that 1 second contains 1 times 10 to the 6 microseconds. And now I can go from microseconds to milliseconds. 1 second, and we put milliseconds up top, contains 1 times 10 to the 3 milliseconds. Look at the units on this. The microseconds cancel, seconds cancel, and what we wanted is what we get. We have the milliseconds right there. So do our math. Anything in the denominator is divided, anything in the numerator is multiplied. So 30 divided by 10, 1 times 10 to the 6 times 1 times 10 to the 3rd is going to give us 0.030 milliseconds. I actually want to do one more with you. This can be a tricky one. Let's say that we have something that's cubed, all right? Let's say that we have 5 centimeters cubed, and I want to know how many inches. How many inches? Well, actually, no, let's not do inches. We'll stick with metrics. We are going to go from centimeters to meters, okay? So I've got to get rid of centimeters. I put that in the denominator. I want meters, that goes on top. But here's the issue. That's centimeters cubed. This is centimeters. Let's attach our numbers. 1 meter has 100 centimeters. Here's how we fix it. You have to take that entire ratio and cube it. Now that exponent outside the ratio is going to be distributed to everything. If I rewrote it, it would be 1 cubed meter cubed divided by 100 cubed centimeters cubed. At that point, now those centimeters cubed will cancel and we'll be left with meters cubed. So it'd be 5 divided by 100 cubed, and that value will be a unit of meter cubed right there. Unit conversions. Let the units tell you what to do, when to multiply and when to divide. Thanks.